Hello, Alina.
Yes, sir.
Ha. Means you understand the concept of this reaction quotient. Uh, you have an idea about this reaction quotient?
Yes, sir.
Ha. So reaction quotient are the is similar with this equilibrium constant only, but it has not yet reached at equilibrium. So for that concentration, when the equation is applied, we will get the value of reaction quotient. Okay.
Yes.
Acha, you have got the answer for the third one.
No, sir.
So you have problem with the first question. The first question is theoretical only. You have to just write the formula, and that is it. You when you will write the formula, na, this will be the answer. That Q says is equal to concentration of this CH3, this uh, CH3COs, C2H5, and here will be the concentration of H2O, and here you will put the concentration of, just don't put the value, just write the thing, this acetic acid and their ethyl alcohol, and that is it. Okay.
Yes, sir.
uh, and the for third question you have to apply the this data. Okay. So if Kc is not equal to Q, then equilibrium has not yet achieved. Okay.
Okay, sir.
Hmm. Ali, Jovita, any doubt?
No, sir.
You haven't submitted your homework, Ali?
Sir, today I will submit.
Uh, Today you will have, I think, 3 to 4 days holiday after this class. So please do your work and submit it. At least have an idea what this topic is going on, so that it will be comfortable for you. This chapter has been done in your school. Ali, Alina, Jovita.
No, sir.
No, sir.
Okay. So it becomes important for you people to try to solve the question. Then you will understand the concept. Uh, so where were we? Have you understood the last classes which we have discussed? Hmm? Hello. Hello, can you people hear me? Hello, am I audible? Okay, so I have given you some questions regarding KCKP. So in that questions, you have to put the values of Kc in these equations for equilibrium constant. There are some calculations. Please try, and if you got the answer, that's well and good. Otherwise, I'm here to solve your questions. So uh, wait करिए जरा 1 मिनट. So we have already studied effect of temperature and effect of concentration affecting the state of equilibrium. Okay, how the state of equilibrium is changing when we are adding or removing some of the reactant or product. Okay, we have also done some examples. Okay, further in this topic only we will see effect of pressure. Effect of pressure. Effect of pressure. So for example, with example we are going to understand it. For example, N2 is gas which is reacting with 3H2 and giving ammonia. It is in equilibrium with formation of ammonia which is in gaseous state. Okay, now I'm asking you people question, please respond. We are going to increase the pressure. Okay, in one case we are increasing the pressure, okay, of this system, of this equilibrium system. Has already been achieved and we are increasing the pressure. For example, it is in for example, this is a container, okay, and we have added N2 and H2 here, okay. They have reacted and also formed NH3. So these container, so this container have nitrogen, hydrogen and ammonia as well, okay. Three components are present in this system. uh, uh, you have to tell me that we are increasing the pressure means we are moving the piston in downward direction, okay. Thus pressure has been increased. Now this is the position of the piston. Now the pressure has been increased. Please comment that will the reaction will go in forward direction or in backward direction, or no change will happen. Will N2 and H2, nitrogen and hydrogen, will start reacting more and will form more ammonia, or ammonia will start dissociating itself into nitrogen and hydrogen? Remember what we have to do according to this Lee Chatterjee principle means according to this, equilibrium wants to remain in equilibrium. They will resist any change in the system, okay. So what change we are doing? We are increasing the pressure. So what will happen? Will ammonia will dissociate and form nitrogen and hydrogen, or nitrogen or hydrogen will combine themselves to form ammonia? Uh, Please means think on it. Ali, what do you think? You can everyone you can message on in the chat. Okay, okay. I'm repeating the question. Question is the system has nitrogen, hydrogen, and ammonia. Okay, this is in the system is in equilibrium. Okay, equilibrium has already been achieved. Now we are increasing the pressure. We are like pushing the piston in the downward direction as pressure has been increased. So in this case, you have to tell me, will the reaction go in forward direction or will reaction go in backward direction? जो भी था, अली, अलीना,
Yes.
अबीर, Please either means turn on your mic and give the answer, or you can message in the chat. Please respond. Please bear in mind that when we are increasing the pressure, from outside, the system wants to remain in equilibrium, right? So they will somehow wants to decrease the pressure so that it remains in equilibrium. So most of you have given the answer. So let's see. When we increase the pressure now, so pressure has been increased, system will shift the equilibrium towards the direction which has less number of moles of gas. See, if you can understand, please see. We are increasing the pressure. Okay. So system pressure has been increased. It wants to, once again come into equilibrium. That is why the direction of the equilibrium will shift in such a way where lesser number of moles of gases is forming. Okay. Are you getting this? So that the pressure could somehow get decreased. And when we decrease the pressure, somehow the system wants to increase the number of, again the pressure could increase by the system. So if we decrease the pressure, system will shift equilibrium in such a way where more number of gaseous mole is formed. Gaseous mole is forming. Are you getting this? When we are decreasing the pressure, system will shift in such a way, equilibrium will shift in such a way that more and more number of gaseous mole is forming. Okay, so that when more number of gaseous mole will form, then the system pressure will again start increasing. Got it?
Yes.
It will, every equilibrium will resist the change. What change we have occurred in the second case? We reduce the pressure. So system will want, equilibrium will want to increase the pressure. Okay, how they can increase the pressure? By increasing the number of mole in this, increasing the shifting the equilibrium in such a way that more and more gaseous mole will be forming. Got it? In this case, for example, when we have decreased the pressure of this, so where is the number of gaseous moles? More number of gaseous mole. Here we have 4 gaseous moles, and here we have 2 gaseous moles. So when we decrease the pressure, the system equilibrium will shift in this way. Why? Because in this way we have only 2 moles of gas. In this side we have 4 moles of gas. So equilibrium will shift in backward direction. In the first case, when we are increasing the pressure, you can understand it also. When we have increased the pressure, more and more moles of nitrogen and hydrogen start reacting, so that only when 4 moles are reacting, only 2 moles of gas are forming. So again, pressure will start decreasing. We have increased the pressure from outside. System will act in such a way that it will decrease the pressure of the system. Got it, everybody?
Yes, sir.
Jobita, Ali, Alina,
Yes, sir.
है ना? Good. So please do some questions. Uh, Note it down. Please answer in chat box. You can answer one by one also, no problem. You don't have to give all answers at a time. Jovita, Ali, Jesslyn, Alina. Hello.
Yes, sir.
Presenting, sir.
Respond with the answer. Uh, Write B for backward, F for forward. That's it. Like if you are getting like this 1F, 2B, 3F, like this. In each and every case, effect of temperature or pressure or concentration, the system wants to resist the change. It wants to remain in equilibrium. Whatever you do, they wants to do the opposite. Jovita, answer other as well. So we are going to solve the questions. Most of you have given the right answer. See, and the first one, let's see effect of pressure find the effect of increase in pressure. So when we are increasing the pressure, what will happen? We have to first check that number of gaseous moles on both sides. So number of gaseous mole in reactant side is 2, and the product side is also 2. Sorry. So this means when we will increase the pressure or decrease the pressure, no matter what we will do, nothing will affect the equilibrium. Okay, so no effect. No effect because number of gaseous moles are same in both sides. Okay, so change, we cannot see the change in the this equilibrium. Okay, got it everyone? Jesslyn, Jovita, Ali, you are correct. And the second option, 2CO plus O2. So we have 3 gaseous mole this side. We have 3 gaseous mole in the reactant side and 2 gaseous mole on the product side. Okay, we are increasing the pressure. Okay, we are increasing the pressure, then the gaseous moles are more in this side, lesser in this side, so the reaction will shift in forward direction. Okay, so that lesser number of moles of gases will form, and hence the pressure of the system will decrease. Got it? The next one we are going to solve. We have carbon, hydrogen, and methane. Carbon is in solid state. We have 2 moles of hydrogen and 1 mole of methane. So when we will increase pressure, so the system wants to decrease pressure. Here the number of moles of gas is lesser, so equilibrium will shift in forward direction. Okay, now the fourth question. Here 2 moles of NO2, 1 mole of N2O4. So after increasing the pressure, obviously system will move in forward direction only. Okay, uh, means the questions are selected that they are all are moving forward. No problem. System can move in backward also. Uh, for example, the last one, 2 VrCl and bromine says. So both have this here also 2 moles of gas and here also 2 moles of gas. So system will have no effect in the equilibrium. Okay, everyone understood?
Yes.
Jaslin, one question for you was no, your questions you got the wrong answer. Have you understood this? You have got correct one also and wrong also. Have you is your concept clear now? Hmm? First one, okay, I will explain. Which first one I will repeat. Okay. Uh, any other one which you want repetition? Ali, जो भी था, Abir, third one. Okay, third one. So we have two questions to repeat. Any other questions? Yes or no?
Yes.
Okay. So let's see the first one. First one says hydrogen and iodine, and we have two. So 2 moles of gas is present at reactant side also, and 2 moles of gas is present at product side also. Okay. So since uh, the number of moles on both side are same, okay, and state the system is already in equilibrium. So when you will increase the pressure, hydrogen and iodine and this Hi, they are already in equilibrium. Okay, and we are increasing the pressure. So number of moles at the of the gaseous states on reactant side and product side are same. So no change will occur. Okay, we will see no change. Why? Because the gaseous moles on both sides are same. uh, H2 and I2 will start, for example, when you will means think on this, that hydrogen and I2, iodine will more and more, because of increasing pressure, they will start reacting more. Okay, but when this they will form 2Hi na, hydrogen iodide, hydrogen iodide will also break in such a way that equilibrium is established. So overall we will see no effect in the equilibrium. Okay, overall the forward reaction and backward reaction are balanced in such a way that overall we see no effect. Okay, now third one. Acha, understood, Jaslin?
Yes, sir.
Third one, okay. uh, See, first of all, in third one was, what is the different about third one? We have to leave this carbon which is in solid state. Already we know that we have to only check for gaseous moles. Okay, so in the reactant side we have two, the product side we have one. Okay, when we are increasing the pressure, okay, the system wants to decrease the pressure. Okay, how it can decrease the pressure? Where it will see less formation of lesser number of moles. The lesser number of moles is formed at product side, so it will move, wants to make more product to. That is why forward reaction is, the more and more forward reaction is done, means is going on, so that system's pressure will start decreasing. Got it, Ali?
Yes, sir.
Hmm. Okay. Moving on. We will see the effect of change in volume. Effect of change in volume. So, effect of change in volume. When volume increases, we know as volume increases, as volume increases, what happens with pressure? When volume increases, pressure decreases, right? If you have some doubt, you can see from this. You have already done thermodynamics. When we will increase the volume, when we will move the piston in upward direction, what will happen? When volume will increase, pressure automatically decrease. Okay. As volume increases, pressure will decrease. Okay. So from this point, we can understand that the equilibrium will shift in such a way, again the same concept, in such a way that more gaseous moles are formed. More gaseous moles are formed. Okay. You can write for more understanding, to counterbalance to counterbalance what? To counterbalance change in pressure. है ना? And since pressure has been decreased, we want more and more number of gaseous moles so that pressure could increase. Okay. And that is how equilibrium will be established again. Have you understood? बोलो भाई. Yes or
Yes,
no?
sir.
Hmm. Let's see the another case when volume is decreased. So when volume will be decreased, the pressure will increase. When pressure will increase, equilibrium will shift in such a way, will shift in such a way that lesser gaseous moles are formed. Okay. Got it, everyone? बोलो भाई, means have you understood? Alina, Abir,
Yes, sir.
Ali. Hmm.
Yes, sir.
Hmm. Please note it down. Done?
Yes.
So we will see another effect. After seeing the effect of concentration, effect of heat, effect of pressure, effect in volume, effect in change in volume, then effect of addition of gas, inert gas. Means this will not increase or decrease the reactants or product because they are inert in nature in that reaction. Okay, and then we will see effect of catalyst, that will be the last one. Okay, so mm. So effect in changing when we are two cases we have taken. We are adding inert gas in the system. We are adding inert gas in the system when volume is constant, at constant volume, uh, at constant volume. Okay, and another case at constant pressure. Okay, for example, this is the system. Okay, and this is the piston on, and we have several reactants and products of a reaction, and we are adding more and more inert gas. Okay, we are adding more inert gas at constant volume, means this piston is rigid. The first case, the piston is rigid and it is not going to move up or down. So we are increasing the sorry, we are adding inert gas. Okay, so the first case, the this vessel is closed, this piston is rigid. Okay, so can you understand that pressure will increase, pressure of system will increase, right? When we add pressure in any gas with constant volume, will the pressure increase or not?
Yes, sir.
है ना? So pressure will increase. So the similar case which we have studied, when pressure will increase, when pressure will increase, what will happen? Equilibrium will shift towards lesser number of gaseous mole, lesser number of gaseous mole. Understood everybody? है कि नहीं?
Yes, sir.
हाँ. So this is plain and simple. Okay, at when we add inert gas at constant volume, pressure of the system will increase. Huh? And when the pressure of system will increase, the equilibrium will shift in such a way that where the gaseous mole of the product or reactant, whichever is lesser, it will form that only. So that pressure will again lower. Okay, let's see the other example where uh, at constant pressure we are adding, we have a piston, okay, which is movable, and we are adding inert gas. Okay, we are adding inert gas. So what will happen in this one? So piston will start moving upward. Okay, obviously piston will start moving upward, right? Yes or no, ji?
Yes, sir.
So when we'll adding inert gas, piston will start moving. So pressure means pressure is not changing, pressure is constant. So at constant pressure we will see no change in the state of equilibrium. state of equilibrium. You can understand it like when inert gas is added, they will take some space of their means whatever space they want, and it will not disturb the equilibrium state of the system. Okay, बोलो भाई.
Yes, sir.
Hmm. So please note it down. I'm giving you a question. My screen visible?
Yes, sir.
Done? Done writing the this thing? Please solve this. Done? Forward direction or backward direction? Please answer in chat. Please answer in chat box. Forward direction or backward direction? Got answer from 3 people. Please answer. Jovita, are you getting? Okay. See. So let's see. We are adding helium gas in this equation, in this chemical equation. Okay. Helium gas is a neutral gas. We are not adding hydrogen or carbon monoxide or CH3OH. Okay. That will be a different thing. The first case where concentration is changed. So we are adding helium gas. Helium gas is added in the system. Then what will happen? The pressure of system will, the first case we are taking, the pressure of system has been increased. Since the pressure of system has been increased, we want to decrease the pressure. We want to decrease the pressure. So where the pressure will decrease, we have three total, 1 2 plus 1 3 side here. Okay, 3 gaseous moles this side, and 1 gaseous moles this side. Okay, so obviously this side, product side, is the number of gaseous moles is lesser, so equilibrium will shift towards forward direction. So equilibrium will shift towards forward direction. Why? Because in the product side we have lesser number of mole of gas, so it will try to achieve equilibrium by decreasing the pressure of the system. Okay. Now the second case, we are constant volume. At constant volume, please remember, when inert gas is added at constant volume, no change will occur. No change. Okay. So most of you have given the right answer. Good. Now effect of catalyst. So what hmm, effect of catalyst? Catalyst. We have already stated in first lecture, second lecture also, that catalyst have no effect, no effect in on the state of equilibrium. No, no effect on the state of equilibrium. What does catalyst do then? It just bring the equilibrium condition earlier, which than expected. Okay, it just bring the equilibrium earlier. Like if the equilibrium was going to establish in 1 hour, catalyst will bring the chemical equilibrium in 5 minutes. Okay, this is the work of catalyst. However, the state of equilibrium will have no effect when catalyst is added. Got it, everybody? बोलो भाई. अरे कुछ तो बोलो, yes or no?
Yes, sir.
Good. Hope you have written. Okay. So we are going to start a new topic which is related with this equilibrium only. but we are going to study ionic equilibrium. Ionic equilibrium. Ionic equilibrium. So by its name, we can understand that we are going to study about ions in this chapter. Like for example, some ions will be studied, okay, uh, in aqueous medium, okay, and their equilibrium with some molecules. For example, these are ions, right? These are ions, and this is a molecule, okay, have no charge on it. Another example which we will study here, like there will be some ions, okay, which will react with some ion which will be in equilibrium with some other ions, okay, like C plus D minus, okay. So here everything will be ion, okay. So ions, how ions are in equilibrium, what is their effect, what is the acidic nature, basic nature, है ना, the salts, strong electrolyte, weak electrolyte, we are going to study in this chapter, ionic equilibrium, okay. So there are some, yeah, अच्छा, understood till here, copied the above thing. Hmm?
Yes, sir.
Hmm. So we are going to study about some electrolytes. What are electrolytes? Electrolytes. Elect Electrolytes. Huh. So uh, substance which conduct electricity. Substance which conduct electricity. Electricity in molten or aqueous state. Okay. Uh, this copper wire which you see, your or aluminum wire which runs in the home, they are not electrolytes. However, they conduct electricity. The which are in the substances which are in molten or aqueous state and which are conducting electricity are known as electrolytes. Which conduct electricity are known as electrolytes. Okay. What are some examples? Electrolytes. Like for example, we have NaCl. NaCl in solid state, let me tell you, in NaCl, the common salt or the table salt which used daily in our food do not conduct electricity in solid form. But when it is in molten state or in aqueous medium, they conduct electricity. Okay. So like NaCl or HCl or KOH. Okay. So this is a acid, this is a base, this is a salt. So these are electrolytes. Okay. What happens is, for example, this is a very popular example. When NaCl is added into water, it readily converts into sodium ion and chlorine ion. Okay. So when they are mixed in water, we have to write in aqueous state. So in the water, they dissociate itself and become sodium ion and chloride ion. Okay. Understood? Yes or no? है ना?
Yes, sir.
हाँ. So electrolytes are categorized into two forms: strong electrolytes and, like we have seen the dissociation of sodium chloride. एक second, हाँ, we have seen we see that every sodium and chloride ion is dissociated. Okay, that is why I have not made the symbol of this equilibrium symbol. Okay, because the reaction goes in one direction only. When the reaction is in both directions, then we show it with equilibrium sign. Okay, so we have strong electrolyte. Strong electrolyte. Let's see what strong electrolytes are. Understood till here?
Yes, sir.
Huh. So for a strong electrolyte, the means the definition is they show complete dissociation. They show complete dissociation. Complete dissociation into ions. Okay. There are some electrolytes which do not show complete dissociation. We will look into that. Have you copied, everyone copied the above thing? बोलो भाई, yes or no?
Yes, sir.
So its examples are example like H, HCl, NaOH, KCl, KBr, KI, है ना? These things. For example, more NaCl, CSCl, all are these strong electrolytes. What happens is when you mix them into water, for example, we have HCl and we have mixed it with water. What will happen? They will completely dissociate into H, H plus and Cl minus ion. Okay, and this H plus will react with H2O and will form H3O plus. Okay, this is called hydronium ion. That is not important here. So these two will form in aqueous state. Other example, which this is the other example where NaCl will dissociate into Na plus Cl minus. There is complete dissociation of ions. That is why they are known as strong electrolytes. Okay, since they are they completely dissociate itself, that is why they have the full capacity to uh, for the transfer of charges. Means they are means they show electricity conduction of electricity very good. Okay, other point we have is weak electrolyte. Weak electrolyte. Weak electrolyte. Okay, so what is the thing with weak electrolyte? They will not show complete dissociation. Okay, so they show partial dissociation. Partial dissociation into ions. Okay, they show partial dissociation into ions. It is around means less than, just for the knowledge, less than 5%. Okay, only 5% has been will dissociate. Okay, for example, some example of weak electrolytes are, the most popular one is CH3 COOH, acetic acid. Then we have, this is as a weak base, है ना? Ammonium hydroxide. Then we have HCN. Okay, we have NH3. Then there are several like these weak electrolytes. So what is meant by partial dissociation? So when we mix, for example, CH3COOH in water, what will happen? Hmm, they will dissociate into CH3COO minus ion and H3O plus ion, or you can say H plus ion. Okay. uh, in aqueous state, obviously they are in aqueous state. Okay. So they will be, since there is no complete dissociation, so there will be in equilibrium state between these two things, means these molecules and these ions. Okay. This is meant by complete sorry, partial dissociation. Okay.
Yes, sir.
Hmm. So dissociation is not complete. That is why they are weak electrolytes. Okay. And like only 5% of will be dissociated, and rest 95% will be this molecule only. Okay. So you can write note like at equilibrium CH3 CH3COOH molecule is in equilibrium, है ना, is in equilibrium with its ion. Okay.
Yes, sir.
Here less than 5% dissociation. Okay. 95% remains molecule, only 5% has converted into this. Ali, I haven't understood. You are asking or you are just completing?
Completing, sir.
Okay, okay, okay. Understood till here? Jovita?
Yes, sir.
Hmm. Please copy. Done?
Yes.
Okay. Done, everybody? So after having this, we will study mostly na acid, bases, and salts only. Okay. So we will moving to next topic. We will understand the acid and bases, acid and base. Okay. And we will study acid and base via different rules and concepts. Okay. So first one and the most popular one is Arrhenius concept of acid and base. Uh, then we will study Bronsted Lowry concept of acid and base. Then we will study the Lewis concept of acid and base. Uh, so let's see. Hmm. The first one we will study about Arrhenius. Arrhenius acid and base. So Arrhenius was a scientist. He was the first one to define what acid and base are. Okay. So for acid, he said that for acid he said that acid are the one is which give H plus ions in water. Okay. So acid are that substances which gives H plus ion in water. Okay. And base are that substances which gives एक second gives छूट गया which gives OH minus ion in water. Okay, only this much definition was given by Arrhenius. Example we have is HCl, HNO3, HI, H2SO4, CH3COH, CH3COOH. Okay, so all of them are giving H plus ion in water. Okay, and H plus ion will react further with H2O to give H3O plus, but these are H plus only. Okay, these are H plus ion giver. Okay, and bases examples are like NaOH, the most popular one, KOH, NH4OH, COH, all twice. Okay, calcium hydroxide. So can you see these all have OH with them? So they will give OH in OH ion in water. Okay. Another way to represent is H is attached with some molecule. When we put it in this in H2O, it will give A minus and H plus ion. That is it. This is the definition of acid. है ना? This is the acid. And for base, we will have BOH. BOH. This is the base. And when we put this in water, it will give B plus plus OH minus. And that is why this is the base according to Arrhenius. Okay. Yes or no?
Yes, sir.
Hmm. So other points you should note that strong acid will completely dissociate. Complete. There is some problem with this pen. Completely dissociate. And so is strong base. Strong base will also completely dissociate. Okay. However, weak acid will weak 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 acid will partially dissociate. Will partially, as we have mentioned in the above, CH3COH was partially dissociating. So it was a weak electrolyte. It was weak acid as well. So weak acid will partially dissociate. Partially dissociate. Dissociate into weak will dissociate into H plus. Okay, and that is why it is acid according to Arrhenius. And weak base, weak weak base will partially dissociate. Got it, everyone? Yes or no?
Sir.
Sorry?
Yes, sir.
But according to there are some limitations as well of Arrhenius. Arrhenius said that the for example this when we studied today, like NH3 is also a base. Okay, is a base, but is a base. Okay, we know this today is a base, but uh, Arrhenius do not take it as a base. We have like calcium oxide, so it is not, it is a basic oxide, but uh, base is a basic oxide. But Arrhenius, since it will not give OH minus, so Arrhenius do not take it as a huh. So Arrhenius did not consider this as a basic thing. Okay. Other thing which he missed is, like for example, we are seeing its limitations. है ना? Example like we have NaHCO3. Okay, this is a salt. Okay, when you put this in water, what will happen? It will dissociate into Na plus H plus CO3 2 minus. Okay, so it is giving H plus. Okay, but is also giving Na plus. So according to Arrhenius, only uh, only positive charge should be of H plus only, but it is dissociant. The Na plus ion is also present, so that is why this is not Arrhenius acid. This is not Arrhenius acid. Why? It is giving H plus, but it is giving Na plus also. Okay. Another example you can take is, for example, we have the CuOH Cl. If you put this in water, what will happen? It will convert into Cu2 plus OH minus plus OH minus plus Cl minus. Okay. So if only OH minus will be present, then it will be a base. But because of Cl minus is also present, this is not Arrhenius base. Okay. These things are this limitations is not much mentioned in NCERT, but still uh, I have mentioned it here. Okay, got it, everyone?
Yes, sir.
Limitation you can skip, no problem. Have you written the above thing? Arrhenius acid,
Yes.
please write. In limitation, you will just write. I am just writing for you. NH3 CaO MgO. According to him, these are not acid or base, so there are some limitations. NaHCO3 है ना, CuOHCl. Write this as limitations. Limitations. These are the limitations. They have acid and basis property, but Arrhenius don't want to accept it. So these are some limitations of it. However, we study Arrhenius according to Arrhenius. Why? Because he was the first one to give definition about this. Done.
Done.
Done, everybody. Now the other one was Bronsted Lowry. Bronsted, he has his own concept. Bronsted, there are two scientists, Bronsted and Lowry. Bronsted and Lowry, acid base. So according to him, acid are what? Which gives H plus. Okay. And bases are what? Which has the ability to accept H plus. So Bronsted was not talking about H which dissociate. The Arrhenius talked about which dissociate H plus is acid and which dissociate into OH minus is base. But Bronsted said the acid are the one which gives H plus and bases are the one which accept H plus. Okay. Understood everybody? अरे yes or no कुछ तो बोलो. So for example, when HCl is reacting with H2O, is becoming H3O plus and Cl minus ion. Okay. So what we are seeing here is HCl is converting into Cl minus. So can you people say that HCl has denoted electron so that it has become Cl minus, right? Yes or no? So HCl has donated electron, right? Sorry, donated H plus. अरे बोलो भाई.
Yes, sir.
So HCl is an acid according to Bronsted Lowry. Okay. Now other thing what we see here is H2O. H2O has become H3O plus. So we can say that it has accepted H plus, right? It has accepted H plus. So that is why he said that this is a base. Okay. Yes or no?
Yes, sir.
Another example you can take is for example, we have some base NH3 and it is reacting with H2O. Okay. And it is in equilibrium, means HCl will completely dissociate but not NH3 and it will become NH4 plus OH minus. Okay. This is the reaction. So let's see what is happening in happening is NH3 is becoming NH4. Okay. So we can see that NH4 has accepted H plus, right? So it has become acid or base. This NH3 has accepted H plus. Is it a base or acid?
Yes.
base, since it is accepted H plus, and H3O has become H2O has become OH minus. So it has donated one H plus. That is why it has become minus and OH minus. So this is a acid according to Bronsted-Lowry. Understood, everyone? Hmm?
Yes, sir.
Yeah, Hana. So we are ending the session for now. Uh, I will give you some questions. Okay, we will discuss it later. Okay, thank you, everyone. Assalamu alaikum.
Sir, can you show limitation?
Limitations of Bronsted-Lowry.
No, the above one.
Okay, okay. Understood?
Yes.
So Bronsted and Lowry and this RNAs have totally different definition. The Bronsted-Lowry is still left. We will continue in the next session.
Sir, can you scroll?
हाँ हाँ